So, your senior engineer just quit to focus on his career making ceramic teapots, and now your manager wants you to scope out the big project because you did so well on that bug last week. Now, unfortunately, you have no idea what the you're doing, so you've come to another Indian coding YouTube channel to teach you how. Well, let's get into it. Today, we're going to look at a bunch of different types of risk that can affect your project and how we're going to mitigate them. This includes scoping risk, technical risk, and timeline risk. So what's the point of tech scoping in the first place? In 2 words, reducing uncertainty, or in 1 word, predictability. There's a lot of things that can go wrong during a project, and it's your job to make sure that everything is accounted for. So there's several types of risk that you want to focus on during your tech scoping. There's scope risk. What are all the granular things that you need to do in order to complete the project? If you're adding a new workflow in, there might be API changes, there might be data model changes, you might need to update the GraphQL mutations. If there's existing stuff going on, maybe you need to dual write with old data and new data. All of this needs to be accounted for in the document. But on top of that, you need to make sure that you're not overcommitting on the project. If there's a certain timeline that you want to get a certain set of features out by, it's your job to push back if you feel like that's not doable. Next, we're going to talk about technical risk. The first aspect of technical risk that we're going to talk about is correctness. Does your chosen implementation successfully solve the user's problem across all the different dimensions of the product? If you're adding a new workflow in, have you accounted for all the data model changes, the GraphQL or API endpoint changes, the new infrastructure you might need? There's really a whole slew of external things that you need to kind of be focused on to make sure that everything is accounted for. You also need to make sure that the old system plays nicely with the new parts that you're adding. So if you have an existing CSV export, are you going to need to add new fields into the CSV export to remain correct? If you have an API endpoint, are you going to need to make any updates to make sure that the new workflows are accounted for via the external API? A lot of this comes down to product context, so make sure that you talk to your PM, talk to your eng manager, and talk to people who have historical context if that's not you. The next aspect of technical risk that we're going to talk about is performance. We want to make sure that whatever implementation we choose is going to have a good level of performance for our users. That means that you're going to have to understand what the volume of data is going to look like. Is the load pattern read heavy or is it write heavy? Based on that, do we need database indexes or do we need to partition the database table? Sometimes the answer is not going to be obvious, and so you're going to have to run experiments, whether that's locally or in the cloud, to get a better understanding of how you're going to have to scale the system. If your database query is taking 10 seconds to run on your MacBook Pro that your CEO gave you pre-interest rate hike, then you're probably going to need to make some efficiency gains. The last aspect of technical risk that we're going to talk about is quality. So you want to make sure that your chosen implementation is scalable and maintainable. If you're choosing to duplicate some code to get the job done kind of quickly, right, which can happen during implementation, you've made a correct implementation, you've made a performant implementation, but you have sacrificed maintainability because now you have 2 sources of truth for the same behavior. This is a problem, and you want to make sure that as much as possible you figure out the high-level details and kind of the intimate details of your implementation in advance, so that when people are going off and doing their own tickets, they have a kind of unified view of exactly what the interfaces and the classes and those kinds of things are going to be. This is hard to do in advance, but if you can have a little bit of forethought around how you want the different parts of the system to interact, it can really lend to a super maintainable and scalable and easy to work with system down the line. Lastly, we're going to talk about timeline risk. Based on how much work you have to complete and how many resources you've allocated to the project, how long is it going to take to complete? One of the best ways that I've found to get a general sense of this is to exhaustively break down your list of work into the smallest possible pieces, and then also use historical data around the team's velocity to basically extrapolate how long the project is going to take. You want to assign story points or basically give time estimates around each piece of work, and then track your team's ability week over week or sprint over sprint to basically complete work and figure out the volume. Once you have a good amount of historical data around this, you can actually get pretty reasonable predictions for how long a project is going to take if you are able to scope things down and kind of point them or time them accurately. Obviously, there's error here, but this system is a lot better than flying blind, and especially if you can find empirical evidence around how fast your team is able to operate, you'll get a decent sense of how long the project is going to take. Now, all that being said, at the end of the day, a plan can be useless. but planning is essential. You want to make sure that you've gone through the exercise of thinking through the whole implementation, the whole system, making sure that you haven't missed anything so glaringly obvious that it's going to throw the entire project off the rails. At the end of the day, if a giant performance issue comes up or a complete workflow is missed, that's not going to look good. When you're leading a project, you get accountability. And accountability is a double-edged sword. On one hand, if the project goes really well, this is going to be a great look and it'll show that you're operating at the next level. On the other hand, if the project doesn't go well, it shows that you aren't quite ready, but that's not necessarily a bad thing. When you go on to the next project, you'll be able to show growth from the project that you've taken on so far. If you found this video helpful, then join our community on School. I'm trying to be more active on there so I can help engineers like you grow to the next level. Thank you.